Hey, all. Today we are going to finish our Unit 2, finally with a discussion on box plots. And we're going to take some of the information we used in the last lesson on measures of position, and we're going to use those to create these things called box plots, which is another way to display data. So first, let's start talking about what is this thing called a 5-number summary. We calculated Q1 median and Q3 in the last lesson, and the 5-number summary. The 5-number summary includes those values, and it also includes the minimum value and the maximum value. So we get 5 numbers, and these are 5 numbers we're going to use to create what I said earlier, the box plot. So let's put this data for the number of meteorites found in 10 states into Excel, and then we will calculate the 5-number summary for that data. So pause here, put this data into Excel, and then we can calculate the 5-number summary together. So here I have my data. I've organized it from smallest to largest, as we typically do. The minimum and the maximum value are easy to find once we do that. The minimum is the smallest, and the maximum is the largest. We find the median by telling Excel that we want the median. And you can tell it which cells to choose, or you can just highlight those cells. I tend to highlight them when it's a small data set. Q1 is the median of the lower half of the data. Because this is an even amount of data, we can just choose the lowest 5 values, and we can find the median of those 5 values. And that will give us our first quartile value. And to find Q3, we're using the last 5 values and finding the median. These 5 values make up what we call the 5-number summary. These are 5 descriptive statistics that will allow us to build a box plot, which is a display of the distribution of our data, in this case, the number of meteorites. And it then allows us to talk a little bit about the shape of the data and draw some conclusions. So we're going to use this data again for the meteorites in the 10 states that we just found the 5-number summary for. And we are going to build a box plot in Excel, similar to how we were building histograms earlier or Pareto charts. We want to create a display of these 10 data points. So we are going to insert. We're going to choose our drop down here for the different charts. We're going to go all the way down to the bottom left here where it says box and whisker. We can call it a box and whisker or just a box plot, whichever one you want. Once we click that, we get this display. And now I want to edit it a little bit so I can make it look maybe a little bit nicer for myself, maybe a little bit clearer. We should always edit the chart title. I'm going to call this meteorites. I'm going to right click on my box and I'm going to format this. I don't want it to be filled, so I'm going to say no fill because I want to be able to see all these lines. Let me talk about what these lines represent in a minute. And then I want to edit my vertical axis. I want to zoom in as close as I can to this box plot. So I'm going to go 1 less on my minimum than my minimum value. So my minimum value was 30. So I'm going to make my minimum for my box plot 29. And my maximum was 296. So I'm going to make this 297. So now doing that has sort of zoomed this in. It gives me the full display of this box plot. And so let me talk about the elements of this. This line up here in the positive direction, that represents our maximum value. The line down here represents our minimum value. This first line in the box, this lower line in the box, represents Q1. This line in the middle represents the median, and this line represents Q3. So I'm going to go ahead and I have this copied and pasted. So this box plot displays specifically our 5-number summary. So here is my maximum, my Q3, median, Q1, and the minimum. And Excel has a different way to calculate Q1 and Q3 than we are. There's many different ways to calculate Q1 and Q3. So it might be a little off of what we calculate, but the picture shows us what we need to. So this box represents the middle 50% of our data. This upper whisker is 25% of our data, and this lower whisker is 25% of our data. So even though they look like they aren't the same size, and they're not, they do represent 25% of our data points, 50% of our data points, and another 25%. And in fact, when you go inside the box plot, from our Q1 to our median, that's 25%. From our median to Q3, that's 25%. The difference between Q3 and Q1 that we talked about in the last lesson is that interquartile range. So this box shows us the interquartile range, shows us how spread out our data is between Q1 and Q3. And so we can use this box plot to talk about the shape of our distribution if we follow some of these guidelines. Right now, if I were to turn this image on its side, which I can't, but if I were to turn this image on its side to make this number line horizontal, this might be how I have to picture it when I want to talk about the median is to the left or the median is to the right, or the right line is long or the left line is long. So when I say right, I mean the positive side. When I say left, I mean towards the negative side. So in this box plot, our right whisker is longer than the left whisker. So our right line is longer. Our median is on the left side or the lower side of the box. So we would say that this distribution is right skewed, or sometimes called positively skewed. When we talk about skew, we talked about it for histograms. We had pictures like that. That was right skewed. Pictures like this, left skewed. We talked about this when we talked about outliers, those unusual data points. We mentioned the skewness based on where are the more unusual data points. Well, in this case, to draw this whisker out this far, we must have had an unusual data point as it compared to the rest of them. So this is a right skewed or positively skewed distribution. So I want you to pause here and put these two into Excel, and we are going to create a couple more box plots to practice that, as well as talk about the differences between them. So I put those values into Excel, and I calculated the 5-number summaries for both of them. And I created the box and whisker or box plots for both of them. I changed my my vertical minimum and maximum to be 34 and 73, and here 27 and 121, just so that I could zoom in as close as possible to my distribution. And so if I look at the distribution of, what do we have? Wooden roller coasters and their speeds. It looks like my left or lower tail is a little bit longer. And it looks like my median is just right of the center or just above the center. So I would say this is slightly skewed left or negatively. If I look at my steel ones, this is definitely to the right of the center or above the center. And my left or my lower whisker is longer. So this is also slightly skewed left. So that would mean maybe the minimum speeds on these roller coasters is unusual. Maybe these are smaller roller coasters, or maybe roller coasters designed for kids that at a younger age, and so their speeds aren't as fast. We could also compare maximum speeds. It looks like on average, or the maximum speed for steel is higher. And then if we look at the median, because these are skewed, we want to talk about the median, and we have those. Median's a measure of average, a measure of center. So it looks like on average, the steel roller coasters are faster, as their median's 85 miles per hour, whereas the wooden median is 58 miles per hour. It looks like our IQR is bigger for our steel roller coasters. So our steel roller coaster speeds are more spread out than our wooden roller coaster speeds. And so these are a bunch of things we can talk about when we're comparing two different box plots. We can talk about their shape, if they are skewed or if they're symmetric. We can talk about their center, which in this case is the median. We can talk about how spread out they are. So we can refer to their IQRs. So when I look at this box on the right compared to this box on the left, this box is larger. That means it's got a larger IQR. That means the data is more spread out there. And we talked about calculating outliers earlier. We could calculate some outliers and we could see, hey, does maybe one of these distributions, or wood speeds or steel speeds, do they have any outliers? So what I want you to do right now is I want you to use this data. We don't have any context for the data, but create or calculate the 5-number summary, create the box plot, and then comment on its shape. Is it right skewed, left skewed, or does it look possibly symmetric? So pause, try this one, and then press play for your answer. So here we have our 5-number summary. And on my vertical axis, I went one above my maximum, which is 55, and one below my minimum, 5. So I can zoom in. Looks like my upper or my right tail is longer, and my median is just slightly below the middle. And so that means we have a right or positively skewed distribution. So if you got one or more of these numbers wrong, or perhaps maybe your box plot looks a little different, and maybe we can just help you zoom it in, or maybe get the fill out of there. You don't have to take the fill out, but I feel like it helps you see the median line better. If you need any help with any of these, please do raise your hand before you move on to the practice. If not, move on to the practice while you're working through those. If you get stuck, let me know if you need help. Take your time on them, and good luck.